Okay, so it's 9 o'clock. Let's begin. Before we start, this meeting is organized by Longshan Hobbyist Community, a third-party organization unaffiliated with Longshan Technology or any of the companies, entities, and institutions mentioned in this document. Please limit discussion to open information only. We will not answer questions for products and designs currently under development or testing. Please refrain from making political statements or commentary for the duration of the meeting. And finally, opinions expressed in this meeting are strictly of the individual speakers. And once again, if you would like to join the meeting as a speaker or add anything to the slides, please feel free to contact me or any of the admins in the chat groups so that we can help you.
In case you've attended the Chinese Biweekly meeting on Sunday, for the previous change, I misinterpreted this change on that meeting. So the interpretation above is correct. The interpretation on the Chinese meeting is incorrect. The following three changes reduce the overall relocation table size for the relocatable object files produced by the assembler. If no instructions between the datum to be fixed by a relocation and the relocation target can be potentially removed by linker relaxation, we can see the offset wouldn't change by the linker, so the relocation can be resolved by the assembler itself instead of being stored into the object file. Similarly, if no instructions before the fix up location of an LoongArch align relocation can be potentially removed, the align relocation can be resolved immediately by the assembler as well. So it needs not to get into the relocatable object file. So it won't occupy some space in that file. So the optimization will reduce the size of the object file. The last change simplifies the handling of our LoongArch DTP relative relocations. Dozens lines of dead code are removed, and the ident of those relocations are ignored. The reason to ignore the ident is GCC cites an incorrect ident of 0x8000 for those relocations, fixing up the debug info, causing difficulties for debuggers. The ident of them is actually not so meaningful, so the PSABI of most other architectures already prohibits idents of their DTP relative relocations. So here we can simply ignore it. So even if the compiler isn't updated, the issue is still resolved. In the last meeting, we also discussed some alignment fixes in the linker. The one for LD-R unfortunately caused the kernel modules to contain our LoongArch align relocations. The kernel cannot handle them, and then it fails to load the module. To fix the issue, I made a change to only insert LoongArch align relocations if at least one input has some LoongArch align or LoongArch relax relocation. If there's no such relocation, the linker relaxation will not happen. So we don't need to insert the LoongArch align relocations to ensure the correctness. We can just skip the insertion and fix the kernel module issue. Next page. For GCC, Meng Qinggang also proposed a patch to remove the incorrect ident in the DTP relative relocations. As we've discussed on the previous page, the ident is simply not correct. The patch is still awaiting review. I fixed a bug causing illegal immediates to be generated for the vshuffle for I instructions. The assembler will error out with such an out-of-range immediate, so the bug had caused the packages failed to build, and it's now fixed. Next. In GDB, Hui Li added the capability to resolve the addresses of the TLS symbols. The proper resolution depends on the DTP relative relocation changes in Binutils or GCC, as we've already discussed on the previous pages.
Okay, now for LLVM, Wang Lei disabled the emulated TLS test, which was currently unsupported on the LoongArch backend. This test was introduced by an earlier pull request, which added emu TLS T tracking support for this component, but it was unsupported on LoongArch, breaking the test cases. So this was fixed. Wang Lei fixed missing LASX handling on match half of 128-bit lanes, where it only handled LSX, causing LASX patterns to mismatch. He also fixed a mishandling of VEXTH and VEXTHU operations, where they had been mistakenly handling these two operations. This issue was introduced by an earlier pull request, which added DAG combines for vector extending operations. Rong or Mantoubao fixed a relocation drifting issue when no relocs and emit relocs are specified to the LLD linker on LoongArch and RISC-V. Jessica Clark objected to this patch, stating that the flag should have no effect when linker relaxation is enabled. However, considering that both GNU linker and the mode linker are opted to fix this edge case, this pull request needs further discussion. So for Linux kernel, there are a lot of things happening in the past 2 weeks. So first of all, Chen Huacai merged a patch to register ISA and LPC programmable I/O devices before PCI root bridge. It targets firmware that defines the programmable I/O devices using the system I/O address space, which resulted in access violations within the kernel during boot without this patch. This patch was commonly found on devices with Kunlun firmware and with those with a lot of say parallel ports or serial ports, especially those from ITE. It's likely that they simply reuse code blocks from x86, which turns out to be the only architecture that has a very well-defined system I/O standard, not on LoongArch, however. The patch is now on its way to be backported to stable and long-term branches. Baorong added a patch to use CPU topology from ACPI PPTT if available. This patch has fixed incorrect CPU topology display on 3B6000 when you use, say, LS CPU. This revision also incorporated the suggestion from Xiroyao, which canonicalizes the package IDs. Zhou Bingbing introduced thermal zones and monitoring for 2K0300. It supports several steppings of this chip, and some of the earlier steppings may report invalid readings from its sensor. To accommodate this issue, it prints a warning and falls back to a basically a predefined temperature calculation formula, and in order to maintain normal CPU functionality while avoiding high temperature risks. Zhou Bingbing also pushed the 5th revision of the Longsun CanFD controller driver, fixed several styling and functional issues in the previous revisions, and rebased against the master branch to fix build failures. In the KVM subsystem, Chen Huacai reviewed the ACPI IOVT, so IO virtualization table, from Maobibo, and it merges the 8 patches from the first revision to 3 patches based on 3 major topics, plus 1 changing maintainer file. Maobibo, never mind. And Cui Tao fixes an out-of-bounds read operation in the extended I/O interrupt controller emulation. This bug can be triggered by an unprivileged guest virtual machine, and is possibly a security vulnerability. Maobibo pointed out that his patch set also fixes this specific issue. It also handles other improvements in the interrupt handling. Cui Tao has since withdrew this patch set. So Maobibo's patch will be the one fixing this issue. Cui Tao also added a patch to update vCPU timers after virtual machine migration, mitigating a possible division by 0 issue in a function. Maobibo enhances the extended I/O interrupt controller and the DMS interrupt controller. I'm not sure what the DMS means here. This patch set was revised to the 5th revision. It also fixed several oversights. Maobibo also added a patch to allow PV feature to be overridden until vCPU start. It checks whether the vCPU has been started and allows for the PV feature flag to be overridden if it hasn't, fixing an issue on virtual machine migration. In the BPF subsystem, Nicholas Dudar has added a patch to fix the upper 32-bit not being zeroed extended when performing 32-bit operations. This fix has since been confirmed by Tie Zhuyang, who is quite active in this space. He also stated that this patch has fixed 4 test cases. Yang Tiezhu pushed 2 patches, one being a request for common patch for various optimizations on zero and sign extensions. And he also submitted a patch to clean up that code in build instruction function. And it also removes several unnecessary runtime checks in instructions, possibly bringing better performance. There are also other functional fixes, 3 from Songhu, which all have been rejected, possibly because the patches were they might have been LLM driven, and Chen Huacai was not really happy with what they're doing, so they have been rejected. Li Haofeng mitigated an alloc and free leaks in the interrupt redirection code, and that will be all for Linux kernel. And when it comes to .NET, Liu Wan added support for atomic operations on LoongArch, supporting both the ISA version 1.0 and 1.1. This pull request is currently under intensive review by the upstream, but I think eventually it should be merged. In QEMU, Maobibo fixed an oversight where the constant timer tick mask may be left unset if the constant timer was not enabled. Sein Kirigami added LVZ, so that's Longsun's virtualization extension emulation for the TCG interpreter. The patch was revised to the 3rd revision, and Maobibo also a maintainer, basically he is a maintainer for both virtualization in the kernel mode and in user space application. He posted a series of review comments, so we may see revision 4 forthcoming. Wang Miao fixed a possible race condition on CSR EStat where it may get overwritten by the CPU thread and by other threads at the same time. This should fix random RCU stalls or soft or hard lockup errors on dual vCPU guests. and the random hangs on single vCPU guessed. And I should also note that this patch was directed at the TCG emulator, not the KVM accelerated emulation. And now for box 64, let's have Liu Yang.
Okay, for box 64 in this dev cycle, I added the up 32 bits zero tracking to eliminate some unnecessary BSTR PGD instructions. So basically in x86, when you refer to some 32-bit register, like when you do some like add EX, EDX, because the register name is 32-bit one, but the physical register is 64-bit. So the upper 32-bit will be zeroed out. But in LoongArch, the 32-bit upper 32-bit will be sign extended. So there is a difference. To maintain the correctness, we have to use the BSTR peak instruction to zero up the upper 32-bit explicitly. So what this optimization does is it utilizes the data flow analysis to identify the dead registers. So for those dead registers, because we know that the upper 32-bit value will never be referenced by any follower instructions, so we can remove the explicit BSTR peak. So we can use less instructions to translate the same x86 instructions. So next, I added a compat mode to the dynamic code block dumpling function. This is just for debugging. And I also fixed an error in the extrq and insert q instruction emulation. These instructions are can only found in the AMD CPUs, not Intel's. So we haven't added those instructions to the dynamic. So it's only in the interpreter now. Next, so we decided to disable the box for dynamic SEP by default. The SEP means secondary entry points. So besides the main entry points for translated code block, there can be multiply second entry point. This feature can be used to save some memory because it allows the code flow jumps to a secondary entry point from another block. So in theory, this can reduce some redundant translation of the same code. However, with some testing, we recently found that this is really not good for the branch prediction. So it's not good for the performance. Anyway, it's now disabled by default. User can enable it manually if they want. Next, we added some 16-bit IMO instruction to the dynamic. Also, we added a fast code path to the 16-bit add instruction in dynamic. We also enabled the call return optimizations by default. So this optimization is really good for the performance, but because it has some bugs, we never find out why. So it's been disabled for a long time. But now I think we figured out all the bugs, so it's enabled by default now. We also adjusted the profile for the David Diver game, and the game is now running in full speed on the 3B6000 chips. Next, Xiangjia added the ABI 1.0 compatibility to in the SIG bus handling of the zero tracking, the upper 32-bit zero tracking you mentioned above. Next page, please. Mikula added the Chinese translation of the WAN-related documentation. She also introduced the getting started guide for the box 4 to Langfang PSAP fixed the parsing code for format strings that can contain spaces in between for printf and related functions. The Zhongdago added PopWire libraries to the box 4 bundled library list. And I think that's all for box 64. Thank you.
Thank you, Liu Yang.
Okay, so here's Jiao, and RVM is a system-level RISC-V emulator, and it equips both an interpreter backend and a tracing JIT as backends. And I made the LoongArch JIT backend for it about half a month ago, and it has been merged into the upstream. So benchmarking with CoreMark, note that we have to disable float operations since RVM doesn't JIT compile FP operations for correctness, and the benchmarking shows about 7% with the native performance, or 417% compared to the interpreter. So comparing with the interpreter, the improvement is quite obvious. And here's some benchmark results and some screenshots that RISC-V distribution is running on LoongArch 64 host through RVM. There are still quite a lot of optimizations that could be done in the backend. For example, in direct branch linking and some immediate logging optimizations. I'll have a look for them later. Okay.
All right, thank you, Ziao. And for Postgres, we have had some good news earlier today. The packages for LoongArch is now available from the official APT repository, as I received a email from Christoph Berg. And you may find more information at apt.postgres.org. So if you have any needs to run Debian or any of the Debian derivatives, and would like to install both PostgreSQL in different versions as well as the plugins, you might be interested in this. And now for other upstream updates, as Cyan has noted that his internet connection was unstable, I'll just continue on. So there are a couple issues and requests for assistance that were raised in the past 2 weeks. So Lingdexi submitted a request to add LoongArch support to publish AOT Clang, a .NET AOT cross-compilation and publishing toolchain based on Zig. The author, however, stated that the .NET upstream has not fully implemented publish AOT on LoongArch. So that part would need more attention before this could be support could be made. TOAHI submitted a request to update the firmware on the Longsun 2K3000 AI evaluation board, or the G2K30ZO, and provided the hardware design for the board. So maybe someone could work on it. A community member, interestingly, submitted a request to add LoongArch compiler RT binary to the Chromium Clang toolchain. The upstream has marked the pull request as one fix intended behavior, stating that LoongArch is not officially supported and preferred downstream maintenance. However, the community developer pointed out that RISC-V, another unofficial or community architecture, has received official support in the upstream back in 2025 and requested that the upstream provide explanations for the prerequisite for receiving official report and why as to the two architectures were treated differently. The upstream has not made further comments on this. And now that Cyan is back, I'll give it back to him.
Now we have Crazy Max fixed the support for different LoongArch distro architecture names for this library, the Dockerfile cross-compilation library. The upstream has since merged the pull request, and the next release will include the fix. Hajime Hoshi fixed the struct return stack arguments on the count on LoongArch and the x86-64 as well for Prego, a library to call C functions written in pure Go. The upstream has merged the pull request, and the next release will include the fix also. Mikula published the user's guide for box 64. For now, it's only in Chinese on the longfans.cn website, which is also mentioned before during the box 64 section. And Wang Rui added basic LoongArch support for crash handling, a Rust crash handling library. This is one of the dependencies for the Z text editor. So we are likely going to see the Z editor running on LoongArch 64. And Rookie fixed an issue reported by Mitsuki Mio that the cross-platform compilation system Xmake produces wrong LoongArch binaries. They are which outputs 32-bit binaries on low 64-bit targets, which is maybe the flags or something are messed up. That must be accidental. The upstream has merged the patch into the main branch, and the next release will include the fix. Woogie released this project version 13.2 release candidate 1, a browser based on Firefox XUL. This release included Jade support for LoongArch that can improve browsing experience significantly.
So it's
Next page,
dactyloid.
please.
It's basically a kind of gecko.
Yeah. So that's some older versions of Firefox, I guess. Next page, please.
Yeah, we're there.
Hey, can you hear me?
Yes, there might have been a delay in the... Yeah.
Oh, yeah. So here, Xiao and Fei added LoongArch CPU feature inspection support for the Julia programming language library, the CPU features, and explained that it is a part of a plan to add LoongArch support for the Julia programming language. The upstream has expressed support for the proposal, which is a great thing compared to the Chromium, which compared to the Chromium, And Xu Zhongkai added alternative routine ID interpretation support on LoongArch for the bare metal virtual machine hypervisor, HVisor. ARI improves scalability and low latency performance for virtualization systems. And Yang Jingze added LoongArch target support for the Whois querying tool. The upstream has merged the change and will distribute LoongArch AVI 2.0 binaries starting from version 1.1.0. And Xijiang submitted LoongArch's build support for modular computer system architecture simulator Gem 5. One upstream contributor has approved the pull request.
Okay, thank you. And now for distro and OS updates. First of all, let's start with tips for maintainers. So if you have received reports that your distro no longer boots on systems with the 2026-05 firmware, please consider the following mitigations. One of the ways to do so is to instruct the user to disable DVFS features in the UEFI setup, or apply a downstream patch. The upstream work is currently pending. There might need to be more internal discussion within Longsun to decide how to best approach this issue. And should you consider applying downstream patch inappropriate, please disable Longsun's 3 CPU frequency driver for now. Please also note that the firmware is now considered a technical preview and is not suitable for production environments. And we hope that things will calm down by 2026-08, which is probably coming out in September. And happening in the last week probably, LongGPU and VPU both received their first official ABI 2.0 release. AOSC has ported both drivers to 7.1 and 7.2 Linux kernels respectively. However, for the LongVPU, we have experienced some known issues, I guess. OBS Studio encoding with VA API does not yet work. You'll get a green video. There is probably some issue with YUV to RGB conversion. Chromium may crash whilst decoding H.265 video streams, and GStreamer and VLC might play back garbled videos. So this driver probably needs more work down the line. And now for Rocky Linux, let me give the floor to Mr. Zhao Yafan.
Rocky Linux is a very popular distribution that can replace the CentOS operating system. Rocky Linux is not a rolling release, so it is more stable compared to other distributions like Gentoo or Arch. However, LoongArch is not supported by Rocky Linux. Back in October 2025, a few Longsong staffs requested for the LoongArch support in Rocky Linux. They posted something in the forum of Rocky Linux. However, no other information has been released since then. I don't know if there is any progress. Being inspired by the work of Mr. Sun Haiyong and his work and his book about porting Linux distribution, I decided to port Rocky Linux to LoongArch. And now I have made some preliminary progress. The toolchain and the base system has been built successfully, and now it can run in the KVM virtual machine. I have to admit my work is more likely to be some homework for reading a book, and I still have a lot to do. I need to add the graphic interface components like DTK, LXDE. The installation image should be created, and DDK, Rust, and other stuff should be supported. Now I would like to share my progress on this project, and I hope my information can be valuable for others who is interested in our work. My note, I wrote some notes about my porting. It is in Chinese, but I think with the help of the large model, it can be easily translated to English or Russian. Oh, that's all.
Okay, thank you very much. Yes. Okay, and now for AOSC, a couple news. So Linux 7.1 is for stable repository is imminent, as we are now wrapping up patch set development and testing. Linux 7.1 for AOSC OS includes trackpad fixes for Lenovo Kaitian and Inspur laptops based on the 3A6000 chip, as well as a pre-upstream fix for S3 Resume on the EAE CIS NL60R laptop, which the backlight will fail to turn on after resuming from S3. Whereas the system runs as normally. The upstream patch is currently at revision 2, and it should be due to merge very soon. And it also has seemed to fix ROCm on 16 kilobyte kernel pages as well. So if you would like to test out this kernel, the OMA command is up here. LoongGPU and LoongVPU also received updates. The LoongGPU in particular includes fixes for boards with newer firmware baselines. That's a terminology I got from a Longsong engineer, but I'm not sure what it really means. It does fix GPU initialization or vBIOS verification on these aforementioned devices. LoongVPU is also now available for testing with all the aforementioned caveats. There are also other notable updates. Mesa was updated to 26.1. TDE, the Trinity desktop environment, was updated to 14.1.6 for those who are interested in this. I know a couple folks who likes this desktop environment. ROCm was updated to the ROC 7.14 release. And finally, there were 25 security updates that were released by our maintainers, with 14 critical and 40 high severity vulnerability fixed in these updates. And for Proxmox, I'll give it to Wu Kaiyang.
So in the past 2 weeks, I put upstream updates from the upstream. These are some key updates I included in the past 2 weeks. So the first is the kernel updated to 7.00.14. Release 6, and the Proxmox PV Manager is updated to 9.2.5, and the CoralSync is updated to 3.1.10 release PV3, and the QEMU PV uses is updated to 11.0.2 release 2. It includes some security-related fix for various display drivers and the USB subsystem. That's it.
Okay, thank you, Wu Kaiyang. And now for community news and events, and hopefully, maybe Wang Xuerui is at the meeting.
Hello, can you hear me?
Yes.
Okay, so please refresh the slide. I've made some new comments. I've submitted new content. Right, I think, yeah, okay. So reporting here live from the noisy hack lab at the DevConf venue. The university, the UNLATE in Santa Fe, Argentina. This year, the Longshan hobbyist community has been a sponsor for this year's DevConf, and I've brought 2 machines kindly supported to me, supplied to me by Mingcong and his friends, all the way from China to the other side of the earth in Argentina. So this year, I will be holding a BOF session on LoongArch and Debian's Long64 port at this time, July the 25th, 13 o'clock UTC, which will be local time 10 a.m. and around 7 to maybe 5 to 9 p.m. in Europe and Asia. So please come by. This event will be live streamed on the official DevCon live streams on the DevConf website and maybe YouTube. So please come by and listen to me. Okay, next slide. Okay, so here's the image of the 2 boxes I've brought here. One is 3B6000 rig with the highest spec version of 3B6000 with the 16 cores and 32 threads and 32 gigabytes of RAM and a discrete AMD GPU. And this box, along with the B-Link PVE host, has garnered much attention from attendees in the past few days, and they are thoroughly impressed by the performance and the competitive prices. I mean, I've already managed to distributed more than maybe 20 of Mingcong's business cards. So people would be contacting him for worldwide shipping of this hardware, and like multiple contributors from various projects have expressed desire or positive attitudes towards the LoongArch port of their software. And attendees from all over the world have SSH'd in and played around in the machine, because I provided free SSH access using the conference network. And some attendees have already deployed a Llama CPP and one of their own free software LLM stack, the Day 50 LLM stack on the box, which is quite cool, and they are impressed by the performance running local LLM inference on the device, like running Gamma 4, tens of tokens per second with the CPU alone. But on the other side, I've already encountered several of the unfortunate bugs. So I'm inadvertently bitten by the linker bug producing rlarch align for the kernel modules. So please do not upgrade to the 7.1.4 Debian kernel yet. It's having those unwanted relocation in the modules, and they won't start because USB and NVMe are both compiled as modules in the Debian stock kernel configuration. Nevertheless, I've downgraded the kernel, so it's okay for demonstration purposes. And another unfortunate thing is wired networking wasn't working for the 3B6000 and wireless not working for the 2K3000 PVE box. So I cannot provide a PVE server to the crowd yet, because when I try to tether the box to the wire to the wireless connection of the 3B6000 box, I found there was no wired network interface on the bigger box. So this is quite unfortunate, because once two kconfig options are not being enabled for Debian stock kernel for Long64 port, and Revly has currently submitted a patch enabling the Motocron supporting the Debian kernel, but this one's still not merged, so I will have to rebuild the kernel for now. And after that, maybe that'll do it, just tether the PVE box, but maybe I'll find some time and try to fix wireless for the PVE box, which it's supposed to support. Okay, so here are some pictures for the two machines on display, and that's it.
Okay. Thank you, Wang Xurui. I guess it's even more unfortunate news that there was actually a wireless module on the 3B6000, or maybe that's not working either. But anyway, let's move on. And we'll have finally a special presentation from Aleksandr Zubankov on the performance evaluation of server Longson CPUs in benchmarks.
Yeah. Hello, colleagues, and I can start.
And one moment, let me download your newest PDF.
Yeah.
One moment, it won't take long at all. Okay, we should be good to go now.
Okay, this presentation, second part of presentations, it previews Biweekly. I report about embedded CPUs. There I compare performance of server CPUs. Next slide. Next. And I remind you our approach to performance comparison. We use any benchmark suite from NTTFX to evaluate CPU performance. For each CPU, we use GCC compiler with O3 optimization and a March native used. There you can see GCC versions for each processors. For Longson 3C6000S, we use two GCCs. First one GCC 8.3 from LoongNix and GCC 15.3 from AOSC. And also we use GCC 15.2 for Longson 3C6000D and LCC compiler that compatible with GCC for Elbrus and some Intel Xeon processors, two Intel Xeon Silver that used with GCC 14.3.1 and one Xeon E5 with GCC 16.1.1. Most benchmarks designed for single-thread calculations. Multi-threaded benchmarks are presented for maximum number of threads for evaluation performance of CPU at all. And benchmarks will run several times to estimate the mean and standard deviation. Next slide. There you can see servers that we are testing. Left one is Longson 3000S and Longson 3C6000D. Then Intel Xeon Silver 4310, Intel Xeon E5 2697 V2, and Elbrus 8C2. Next slide. And there I described characteristics of the CPUs. You can see that some CPUs we used in multi-CPU configuration. Elbrus was used in 4 CPU configuration. Have so small number of threads, only 8 cores and 8 threads. And also Longson 3C6000D used in configuration with 2 CPUs, and also Intel Xeon E5 2697 V2 also used in 2 CPUs configuration. There you can see different number of threads and frequency and caches. For each CPU, we use more than 2 channels of RAM. And also, first 5 processors uses DDR4 RAM. Last one, Xeon E5, use DDR3. Next slide. Next slide. Yes, first benchmark, it's Westron. There you see that Longson is pretty good and about at level of Intel Xeon Silver 4310 and Xeon E5 2697, and more than 2 times better than Elbrus 8C2. And there you can see difference between 2 GCCs compilator. New GCC there gives better result. Next slide. Also multi-threaded result. There you see that Longson C6000 better than Intel Xeon Silver 4310 with lower threads. and its performance lower than Intel Xeon Silver 4314, but significantly better than 8 Elbrus 8C2. And if you see at the last column, these two CPUs Longson 36000D with very huge number of threads. Next slide. Next benchmark is Drystone. There you see the same trend. Longson is very close to Intel Xeon Silver's 4310 and Intel Xeon A5, and some lower than Intel Xeon Silver 4314, and significantly better, about 5 times than Elbrus. Next slide. This result of CoreMark benchmark, and there you see same thread is single thread results. And next slide. The multi-threaded result. Last column I shown only as maximum number, and to show difference between other processors better. And there you see that Longsons in multi-thread significantly better than Intel Xeon Silver 4310, and almost as 4314. Next slide. Next benchmark is Super P, that calculated P number. There is time that lower value is better, and best value as in previous benchmarks of 4314, and Longsons very close to Intel Xeon Silver 4310. And there I see some difference between GCCs, and newer GCC shows lower result. Next slide. And next benchmark is LeanPack, and the x86 is better, old processors than Longsons, but Longsons is very close to both Xeons 4310 and E5, and significantly better than Elbrus. Next slide. There is Livermore loops results. There you can see different parameters, not only average, but it's maximum, average, geometric mean, and harmonic mean and minimum rate. And there is in previous slides same trend as I see, better results for Intel Xeon Silver 4314 and Xeons 4310 and E5 very close to Longson. Next slide. And another benchmark is SciMark, and there also you see same trend. Next slide. Another benchmark is MemSpeed. There I see some stranges with different GCCs. First picture is for older GCC, second for newer And there you see that old GCC shows some strange low result. And that's why necessary to check new GCC too. And this benchmark can show caches size. For example, if we see at y-axis, the L1 cache for long zones is 64 kilobytes. Then L2 cache, L3, and RAM. And also you can check caches for other processors. Next slide. Next benchmark is bus speed. This benchmark also can help to check cache size and its speed. And there also we see some difference between GCC versions. First, second picture. And necessary to additionally research it. And next slide. And next benchmark is npm flops, multi-threaded benchmark. And there you see some performance for different number of 4 bytes words and operation per word. And I think that result for long zones is quite good in comparison with Intel Xeons. And I think that for multi-CPU configuration, results is better due to maybe more cache and more memory slots to calculate. Next slide.
Just to clarify, we mean here that brighter is better, right?
Bright is better, yeah, on all pictures.
Okay.
And additional research that I checked, I change compiler from GCC to Clang and compare the results. And for some benchmarks that's easy to compare because some benchmarks have more multi-variable parameters and difficult to compare it. And for example, you can see that most benchmarks gives some lower results at 10% for Clang. Next slide. And go to conclusions. In single thread benchmarks, long zones 366,000S and 366,000D are the level of Intel Xeon Silver 4310 and Intel Xeon E5 2697V2 1.52 times worse than Intel Xeon Silver 4314, but 2-3 times better than the Elbrus 8C2. And as I think, result is relatively stable to changes in compiler to Clang and versions of GCC within 15%. Next slide. In future, we plan to make comparison with other Russian processors, with Baikal ARM processor, also supplement testing in our operation system that develops in our company, and supplement testing in real work tasks as big data analysis or something else. And next slide. Thank you for your attention. I'm ready to ask any question.
Okay, thank you, Alexander. I think we have quite a few. Let's see here. Let's go back to the slide here. Typo. Yeah, no beta label for the 2026-05 firmware. That would have been a mistake. We will fix that as soon as possible. Do we have any question for the presentation or for anything that was presented today?
I have a question. So for the Rocky Linux port, is there any installation ISO available or a public repository for now?
No. For the Rocky Linux, I just this is the status of the project is very preliminary. So
okay,
I only have a virtual machine on my own computer.
So is any of these on the plan?
Yes, but I have to work this in my spare time, so I don't have too much time.
Sure. Because for the PVE, the upstream also provides Rocky Linux RxC container templates. So if Rocky Linux ISO or repository is available, I can also provide Rocky Linux templates to PVE LoongArch port. Yeah, thank you.
No, thank you.
And I can't help but think that others might be interested as well. I've had a couple friends from the United States and from Germany who are also interested in a Rocky Linux port for LoongArch as well. So yeah, there might be some potential here. Okay. And two questions from Aleksandr Shori. So I think the first one is for Alexander. So
yes.
Do you think the performance, I'm assuming, maybe Alexander, you might be able to just read out the question? Yes.
Yeah, thank you so much. Sorry, I just didn't want to disturb. Thank you for the measurements and all the effort. It's a lot of work to do those benchmarks and to compare them. Is it because the GCC optimizations are so much different between version 8 and 15, and I think the current version is about 16, that we have most often a better result, of course, with the new version, but sometimes, shockingly enough, also a worse one? Do we know what happened in between, or is this just the first side that we see there is an issue, but we don't know why? I don't know whether I should expect it to be this way and expect to be GCC 16 even better, or do we have to dig down deeper?
Yeah, thank you for question. And I don't know which optimization used in GCC between versions, and I think results may be better, but for comparison in processors, I think that it's not very important because it's only at level of 10-15%, and I think you can run another application in other terminal, and you see much lower results than if we change version of GCC. And I think, but I think it is interesting to research how this optimization works and how to optimize it.
Yeah, it's definitely very interesting. Yeah, maybe it's something we can take for an internal discussion, because maybe GCC did something good that Loongson also benefits from, or maybe we did something and I just don't know. But okay, thank you so much.
Yeah, thank you.
Yeah, and the second question was about if we already have Rocky Linux in the view and want to support it. It's basically the same with Alma Linux, as far as I know, because many companies here in Europe had the decision to make, okay, now that Red Hat, IBM had different plans, what to do and where to go. And the teams behind Rocky and Alma are a bit different in terms of commercial support, which companies back them, which industries back them. So my clients, for example, chose to go with Alma Linux. And for the first year or two, I think they were almost identical. But now I feel that Alma Linux, for example, allows for more changes apart from the original upstream. Maybe it's worth a try also to look into this direction. I mean, both are somehow relying, of course, on the upstream work from Red Hat IBM, but maybe Alma Linux is also worth a try in terms of if Rocky Linux does not like to support it now, let's go and try and ask Alma. I have no idea if that's a good idea or not, but as pointed out correctly, a lot of companies use this as a base.
Yeah, and I think it's not really in particular a question directed at anyone, but yeah, it's something to think about. And also, I would also like to share as well, a couple experience I've had with upstream projects, either distros or otherwise. Recently, the PostgreSQL news that I shared today, as well as the LXC actually, is really a story of someone asked for LoongArch support. Someone may or may not have said, "Oh, we are no." So someone asked for that support, and then the upstream said, "Oh, okay. Are you going to fund us? Are you going to give us devices?" And a lot of the times, these kind of requests fell kind of under the radar, and people just never supplied the hardware, and then it just fell out. And I guess there are cases where that geopolitics have played a factor, but there are a lot of times where the project just needed more support, either in hardware or in funding. And LXC, for instance, I have personally purchased a 3B6000 for them because they were left in the cold for 5 months. And now that the motherboard is on the way, I'm expecting them to start setting things up in the next month or so. So all that is to say, if there are requests for LoongArch that kind of fell into the code and no one was responding or it's not going anywhere, might be a good idea to kind of post it in the Telegram group, and some of us, either me or other staff at the community or other friends may be able to help. So just as a suggestion. And then a question from Zhao Yafan, is GCC 8.3 running on API 1.0? Yeah, I would imagine so. There is no such thing as a GCC 8 for API 2.0. But not sure about the GCC 15 part, so maybe Aleksandr, you have information on that?
No, I do not have information. Test was conducted about 6 months ago, and I didn't remember. Sorry.
I see. And JH Pay noted that OpenSUSE's open build service can build LoongArch packages under user mode emulation, so everyone can register and have a try. So maybe that is to say that a potential OpenSUSE port can be bootstrapped this way, or are you trying to refer to something else? I guess the other way to ask the question is that, oh.
I remember there was some bug in the user mode emulation causing crashes or something. Are those bugs all fixed now?
On user space emulation, I guess. And Aleksandr noted that in his company that they are developing a CentOS 10 port. He will ask his management if they can share it with everyone. Are you referring to Colab OS, Alexander?
Yeah.
Okay, interesting. Yeah, I was able to take a look at it back in April in Moscow, and yeah, it's in pretty good shape, I would say.
But I think the crash that Shiroya mentioned before is according to my and Bimington's experience on user mode on building packages on user mode emulation, the some of the specific kind of problems are just random freezes due to the mutexes not being released properly. So there was a script, yeah.
And
written
it
by
happens
one
especially
of the,
often with Rust as well.
Yeah. So other issues are not commonly observed under user mode emulations. They are quite accurate. If I have to say, they are actually quite accurate and suitable for. If you really don't have a real machine, then you can just build packages on user mode emulation.
Yeah, and I should also add, on the topic of real machines, there is a challenge that we're facing here with our community here in China as well. We do have virtual machines accessible via SSH or VNC, but we do have the Great Wall of China, and it's pretty hard to circumvent, and reliably, I would say. It's not hard to circumvent, but it's hard to circumvent reliably. So at the end of the day, usually what we end up with is that we'll have to just ship a machine out, and it's some cost, I guess. But what I'm trying to say is that if anyone, say in the Americas or in Europe, if you're willing to host, say 5 to 10 machines, I think that's something we're willing to look into, to help minimize costs in shipping, help minimize costs for the user to set it up with, especially the RAM prices and SSD prices right now. So if you would like to help, please do let us know as well. Okay, do we have any other questions? Okay, I guess I'll continue moving on. If there's no question, our next meeting will be on August 6th, 2026. At the same time, and we'll see you then. Hopefully more news from all the areas we're looking at. And finally, thanks everyone again for joining us, and the QR code points to our Discord server and the Telegram group, and look forward to seeing you all in 2 weeks.